Hello friends, welcome to the video lecture series of Statistics and Probability. So far, we discussed various distributions, random variables, then many measures we discussed in previous lectures, the measures of central tendencies, the measures of dispersion that is standard deviation, mean deviation. Now, we are going to study the important parameter which describe the data. Because if the data is normally distributed, it becomes simple to handle it. If the given data points or the data is not normally distributed, if the data is accumulated on the right hand side of the mean, if data is accumulated on the left hand side, if the data is more picked at particular level, in that case, the measures of pickness and the measures of skewness that we are going to study today. Means the skewness and the measures of pickness, that is kurtosis. Skewness and kurtosis we are going to study. So many people, they pronounce kurtosis as kurtosis. It is also okay, it is up to them. And the one more thing we are going to discuss, that is the moments. In engineering mechanics, moment is what? The moment is the measure of energy which generates frequency. The similar kind of meaning is there in statistical moments. So I will call it as a moments or statistical moment. In statistics is the same thing. Yes, what is the moments? Rth moment about, in short I am writing, Rth moment about the arbitrary point. Arbitrary point, say A. Okay, A is the arbitrary point. Moment about the arbitrary point. This moment about the working mean also, it is called as the working mean also. The moment about the arbitrary point is what? It is summation x data points minus A, this power r divided by n. N is what? Sum of the data points. If data points are 100, n is 100. If the frequency table is given, in that case, you have to multiply this bracket by f only. You have to multiply this bracket by f only. Okay. This is the rth moment about the arbitrary point or working mean, that is A. Then rth moment about the mean, the mean of the data point, say x bar, then summation x minus x bar power r, this divided by. Okay, here rth moment about mean and rth moment about an arbitrary point. Is for the sake of simplicity, is I will denote it by mu dash or mu dash r, like this, and here I will call it as mu r. Okay, it is fully dependent on us how to denote it. Now the moment about the origin. Moment about the origin, there are normally three types of moments are studied. Moment about the origin, moment about an arbitrary point, and moment about the mean. The moment about the origin, here in place of A, you have to put 0 only. You have to put 0 only. Now, the moments about the mean and moments about the arbitrary point, there is a relation between these two. Okay, there is a relation between these two. Now, the moment about the mean, here first moment about the mean I am writing. First moment about the mean. First moment about the mean. That is mu1 and summation x minus x bar. This is RF moment formula. Put r equal to 1 simply. This by n. And first moment about the mean is 0. First moment about the mean is 0. Normally in moments, first 4 moments are important. The first moment about the arbitrary point, it indicates the mean. Second moment, variance. Third moment, it is related to skewness, and fourth moment related to the kurtosis. The first moment about the mean is 0. So we can easily show it. Means summation of x by n. I am separating denominator here. Summation of x bar by n. Okay, summation of x bar by n is the mean itself, is it? Minus, and summation of all mean divided by n again x bar, and it is equal to what? 0. Means moment about the mean is always 0, and that is the first moment. First moment about the mean is 0. Now the second moment, just you put r equal to 2. Second moment about the mean. About the mean of the data is what? It is mu2 equals summation x minus x bar square this divided by n. As I told you earlier, if the frequency table is given, then this must be multiplied by f only, and in the denominator summation of f is n. Okay, throughout the chapter this summation of f is equals n. This you have to remember. Okay, this is standard notation, summation f is n. Then it represent, okay, this represent the variance now, second moment, and third skewness. First of all, I am going to write third moment about the mean. Moment about the mean, simply substitute mu3 equals summation x minus x bar power 3 by n. And fourth moment about the mean, fourth moment about the mean, mu4 equals summation of x minus x bar power 4 this divided by n. Okay, these are the first 4 moments about mean. And first 4 moments about arbitrary point you can find by this way. Put r equal to 1, 2, 3, 4 and so on. Now coming to this skewness. The skewness is what? Skewness. Okay, this skewness measures the lack of symmetry, you can say. It measures the lack of symmetry. Up to which degree the data is not symmetric. It is measured by skewness. Okay. In skewness, in normal distribution, if the curve is normal distribution, or if the data is normally distributed, the mean is equal to mean mode of the data and median of the data. They are same if the data is normally distributed. If the data is not normally distributed, if mode is greater than mean, if mode of the data is greater than mean, then the curve is, this implies the curve is negatively skewed. Curve is negatively skewed. Means if the data is like this, see here, this is normally distributed, this is normal distribution curve, is it? And the data is, if it is negatively skewed, in this way, so I am putting here dotted line, this here is normal distribution curve. In short, I am writing normal curve. Here the data is left skewed. The data is left skewed, means on the left hand side of the data, okay, this will be like this. Okay, this will be like this. Okay, this is the asymptote. This horizontal line is the asymptote to the curve. Now, here the mean of the data. Here at this point, we have mean of the data, and this median of the data. This is median. This is mode of the data, and median will lie between mean and mode. Here, median will lie between mean and mode somewhere else. Here, the mode is greater than the mean. The data is negatively skewed. Okay, means on the left hand side, it is skewed. Now, the positive skewness here. I am drawing here 3 curves so that it will be easy to compare. If the data is like this, here this is the mean at this point, suppose, and mean is greater than the mode. Mean is greater than the mode. The data is positively skewed. Okay, it is positively skewed data. For normal, okay, mean, mode, median are same. When mode is greater than mean, then it is left skewed, and this is what if mean is greater than. One more sentence I am going to write. If mean is greater than mode, then data is, or the curve is positively skewed. It is the positively skewed. Now the coefficient of skewness and kurtosis you can find out. Here the coefficient of skewness, the formula also I am going to give you. Coefficient of skewness. Okay, it can be found out using this formula, mean minus mode divided by standard deviation. Okay, this is sigma. The sigma is the standard deviation. Sigma, here I am writing, sigma is the standard deviation. Okay, sigma is what? It is a standard deviation of the data. Or this formula can be replaced by 3 times mean minus median. Mean minus median, this divided by standard deviation, sigma. Okay. The coefficient of skewness can be found out using this formula. Yes, it may happen that if mean is given, mode is given, mean of the data, mode of the data is given, standard deviation of the data is given. So you can find out coefficient of skewness. Put down the value and get the answer like that. The coefficient of skewness is given. out of this 4, 1, 2, 3, 4, coefficient of skewness, mean, mode and sigma. Sigma means standard deviation. Out of this 4, if 3 things are given, so you can find out fourth one. Here out of this 1, 2, 3, 4, if 3 things are given, the fourth you can easily find. Okay. Now, here the coefficient of skewness can be, measure of skewness also I am writing. The measure of skewness. There's one more formula I am going to write here for the measure of skewness, because it is more popular, and the measure of skewness, it is denoted by beta 1, normally. Measure of skewness is denoted by beta 1, and this beta 1 is equal to mu3 square by mu2 cube. Yes, what is mu3 and mu2? The mu2 is what? Second moment about mean, and mu3 is what? Third moment about mean. Okay, and from here the coefficient of skewness also you can find out. Either you find out coefficient of skewness from this information, or coefficient of skewness you can find out from beta 1 also, from the measure of skewness. Coefficient of skewness I am denoted by gamma 1, and it is under root of beta 1. Under root of beta 1. Okay, this is all about the skewness. Whether the data is skewed on the right hand side or left hand side, okay, that can be judged using this formula. Now, coming to the kurtosis. This kurtosis is what? The kurtosis is the measure of thickness. Kurtosis is the measure of thickness. Kurtosis, it is what? How much the data is picked. How much the data is picked, that we come to know from kurtosis. Okay. It's many times. Okay, you may come across this type of situation. See, 3 curves I am going to draw. This is the normal curve. Okay. This I am going to draw 3 curves here. Like this, and for better understanding, the 3 curves I am going to draw, and which is more picked, that I am going to tell you. Okay, this middle one is what? It is a normal curve. This curve is a normal curve. If curve is normal, then we should not worry more. Now here, this curve is more picked, like this I am going to draw. It is, the thickness is more. Okay, thickness is more. And this curve is less picked. This curve is less picked. Okay, this is described by the kurtosis. This is described by the kurtosis. This is normal curve, and or this is mesokurtic curve. Okay, this is less picked. This is brachykurtic curve. Normal curve is mesokurtic, then the platykurtic, and now this is more picked. This curve is more picked, and this curve is leptokurtic. Which one? Yes, this is leptokurtic curve. Here thickness is more than the normal. Here in normal distribution or normal curve, the thickness is standard. This curve is mesokurtic and this is less thick. Thickness is less. This is platypuratic curve. Okay. Now, here in short, I am going to write. I'll tell you what is beta 2. Beta 2 is a measure of kurtosis. Here beta 2 is less than 3. Here beta 2, when the curve is mesokurtic, it is 3. And here beta 2 is greater than 3. Okay, I'll tell you what is beta 2 and how to find out the value of beta 2. Okay. Now, the degree of thickness we are going to calculate like this. Now, measure of kurtosis, formula I am going to write measure of kurtosis. The measure of skewness we have written. Now, the measure of kurtosis formula, and this is denoted by beta 2. Measure of skewness, it was denoted by beta 1. Now, the measure of kurtosis, I am denoting it by beta 2. And it is equal to mu 4. This divided by mu 2 square. What is mu 4? Mu 4 is the moment about the mean or fourth moment about the mean. And mu 2 is second moment about mean. Fourth moment about mean and the second moment about mean. And square of the second moment is there. And coefficient of kurtosis is up to which degree it is picked. If you want to find out it, this is gamma 2, it is under root beta 2 minus 3. Okay, this is the measure of kurtosis. And if you want to measure up to which degree, okay, this thickness is there, then coefficient of kurtosis gamma 2 is beta 2 minus 3. Now, so when we solve the problem of the moment, in those problems, we have to find out the measure beta 1 and beta 2 also. That's why I explained what is kurtosis and what is the skewness. Skewness refers to it describes the how much the data is left skewed or right skewed. In kurtosis, how much the data is picked. Okay, that we get. Now there is a relation between. Yes, that relation also I am going to write, because when we solve problem, relation between moments about the arbitrary point. You can say it is arbitrary point or working mean is the same thing. Arbitrary point and moment about mean. Moment about mean. Okay. The relation I am going to tell you. What is the relation between these two? Yes, on the next sheet, systematically I have solved the problem on the sheet in order to save time. Earlier I have solved this problem, I am going to explain. Okay. And there the relation between moments about the arbitrary point means mu r dash and mu r dash, relation between mu r dash and mu r, that I am going to tell you. Okay, that is already written on the next sheet, therefore I am not going to repeat here. One problem we are going to solve. See, this is the problem. Okay, and this is the relation between, see, these are the relation between moments about mean and moments about the arbitrary point. Moment about the mean and moment about the working mean, you can say. Working means what? Arbitrary point. And first moment about the mean is always 0. And that I have shown you how it came to 0. First moment about the mean is always 0. Now very quickly, one problem we are going to solve. It is already written on the sheet. Very quickly I am going to explain. Okay, this data is given to you. In examination, you may be given different data, In this problem, this data is given. These data points are given 5, 7, 13, 24, 29, up to 50, and their corresponding frequencies are given. Means in that particular data, 5 occurs 4 times, 7 occurs 6 times, 13 occurs 17 times, and so on. 50 occurs 2 times. Okay, this data is given. What is the question? Find the first 4 moments about the mean. This we have to find. Comment on skewness and kurtosis. Means here we have to find out the moment about the arbitrary point, moment about mean. Skewness means beta 1 and kurtosis means beta 2 also we have to find. After that we have to comment on it. Now this is the table. What I am going to let here, let x is equal to or a is equal to 24. Okay, this is, you can say, the arbitrary point of the data. Arbitrarily you can take any point, or the working mean ones. Okay, if the arbitrary point is given to you, no problem. Here the arbitrary point is not given. I have chosen 24. As far as possible, you try to select. If it is not given, arbitrary point is not given, just try to choose the entry which is in between this. But it is not mandatory, because instead of a equal to 24, you can take a equal to 29 also. You can take a equal to 13 also. But for better accuracy, if you if you find out by taking middle value as far as possible, then it will be good. But you can take a equal to 24, a equal to 29, a equal to 13, and a equal to 36, any point. These 2 columns are as it is, see. Then this deviation I am taking. Yes, what is the role of deviation? If deviation allow our data to shrink, is it? It shrinks the data. Computationally it is more economical if use the deviation. Okay, it is good habit to use the deviation always. The d equals x minus 24. Okay, this x minus 24 means 5 minus 24, 7 minus 24, 50 minus 24, like this. Now the one column is required f into d, because these are the formulae we have to apply. And we have to find out the moments about the working mean or moment about the arbitrary point 24. So that's why all these columns are required, f into d. F into d means this column multiplied by this column, respective entries. Product of these two is minus 76. Product of 18 into 5 is 90. Product of 2 into 26 is 52, like this. Fd square. Take square of d and multiply by f. Is, for example, minus 19 square into 4 is this one. Minus 17 square into 6 into this one. Minus 11 square into this. Minus 11 square is 121. 121 into 17 is, okay, this one. Like this. Now fd cube. Taking cube of it multiplied by f, you get this one. Taking cube of it multiplied by this, you get this one. F d raised to 4, f into d raised to 4. The take fourth power of this, minus 19 raised to 4 into 4 is this one. Minus 17 raised to power 4 into 6 is this one. Likewise, minus means 26 raised to 4 into 2 is this one. Okay, and these are the columns which are required to find out moment about the arbitrary point, mu1 dash, mu2 dash, mu3 dash, and mu4 dash. And sum of fd, summation of all, here I have written, summation of all these entries I have written, sum of fd cube I have written here, means sum of all entries, sum of all those entries I have written here, summation of f d raised to 4 means sum of all those entries. Now these are the formulae for moments about the value 24. Okay, so mu1 dash is summation f d by summation f. Summation f is capital F, mu2 dash is this, mu3 dash is this, mu4 dash is this. Just putting those values here. Summation ft 128 by summation f is 96. 128 by 96 is this. Summation ft square means this entry divided by 96 is this one. This entry divided by summation f is this one, and this entry divided by summation f is this one. So in this way, mu1 dash, mu2 dash, mu3 dash and mu4 dash, all those are moments about 24, moments about the arbitrary point we are for. And the relation between moments about arbitrary point and moments about mean is there. Okay, this is the relation. This relation you have to remember. Moment about mean is always 0, means mu1 is 0. This is the formula for mu2, formula for mu3, formula for mu4. Put all those values here and try to find out it. Means mu2 dash is this, mu2 is this, mu3 is this, mu4 is this, and mu1 is always 0. Okay, these are the moments about mean. Okay, these are the moments about the mean. Here, these are the moments about the working mean or arbitrary point 24. Okay, very quickly, next one. Here, the data is not given directly. Moments about, see, first 4 moments about the working mean or arbitrary point 5 is given. This moment, first moment is 2, second is 20, 40 and 50. These are the moments about the arbitrary point. What we have to find? Moments, central moments. Central moments what? Moment about the mean, actual mean. Actual mean or mean is same thing. Moments about the mean we are going to find. Also find the mean of the data, standard deviation and coefficient of skewness and kurtosis. Okay, many things are asked. Okay, this formula I have copied down here. Mu1 is always 0, mu2 dash. What is mu2 dash? Here, mu1 dash is 2, mu1 dash is 2, mu2 dash is 20, mu3 dash is 40, and mu4 dash is 50. Okay, now mu2 is mu2 dash is what? It is 20 minus mu1 dash is 2 square. 20 minus 4 is 16. Okay, 16 is the second moment about the mean. Second moment about the mean. Now here also you can put the values. Mu3 dash. Mu3 dash is what? 40 minus 3 times. Mu1 dash is 2, mu2 dash is 20, plus 2 times mu1 dash cube. mu1 dash is 4. Okay, mu1 dash is what? 2, no? Cube. Is it? And what is it now? It is 40 and 40 minus 120 plus this is 8, 2 raised to power 3, 8 into 2, 16. Okay, 8 into 16, and this is equal to, this is 56 and minus 120, it is minus 64. Yes, it is minus 64 is the moment about, third moment about the mean. Now likewise you put down the value here. Mu4 dash, mu4 is equal to, mu4 dash is what? Mu4 dash is 50 minus 4 times mu1 dash is what? 2, mu3 dash is 40, then 6 times mu1 dash square, 6 times mu1 dash is 24, 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 6 times u1 dash square. Okay, mu2 dash, what is mu2? It is 20. Then minus 3 mu1 dash raised to 4 means 2 raised to 4. Okay, now the 50 minus this is 320, no, and this is what 824, and 20 into 4 are 80 into 6 480, and this is coming to be, it is 162 mu4 means mu1 mu2 mu3 mu4 are the moments about the mean we have calculated. Moment about the arbitrary point 5 given to you, moment about the mean we have found. Okay, now the mean we have to find. The mean also asked here. The mean is what? Mean is equal to, this is A is mu1 dash plus A, and mu1 dash is what? First moment about, this is 2, and A is what? 5, and it is 7. Okay, this is the mean value of the data we have found. What is the next thing? The standard deviation. Standard deviation what? It is the square root of variance, and the second moment about the mean gives us the value of the variance, which is 16, and the standard deviation is 4. Okay, second moment is related to what? Variance. Third moment is related to skewness, and fourth moment related to the kurtosis. Okay, next thing is to find a coefficient of skewness. Now coefficient of skewness I am going to find. Coefficient of skewness, that is what it is denoted by beta 1. Okay, see this coefficient of skewness formula I am going to use. This I am going to show you. Coefficient of skewness formula. This is the coefficient of skewness formula, mu3 square by mu2 cube. Okay, mu3 square by mu2 cube. This minus mu3 square means minus 64 square by mu2 cube. mu2 is what? 16 raised to power 3. Okay, this is 64 means 16 into 4. 4 square is 16, and it is equal to 1. Coefficient of skewness is what? The coefficient of skewness is 1. Now the coefficient of the measure of skewness, you know, it is the measure of skewness, and the coefficient of skewness is under root of, that is denoted by gamma 1, and it is under root of beta 1, and under root of 1, beta 1 is 1, which is equal to 1. Now coefficient of kurtosis we have to find. The measure of kurtosis I am going to find out. What is the measure of kurtosis? Beta 2 formula. You can see this is the beta 2 formula, mu4 by mu2 square. mu4 by mu2 square, and mu4 by mu2 square, and if you try to find out it, it is 0.63. It is 0.63. Now it is beta 2 is what? 0.63. It is a measure of kurtosis. Now here in measure of kurtosis, where it is, this I am going to, yes, here see, if beta 2 is less than 3, beta 2 is less than 3, then this data is what? Platykurtic. Okay, this data is what? Platykurtic. Yes, I am going to use this pen. Data is platykurtic. Okay, means data is more flat because this is less than 3. Yes, I am writing here less than 3. Okay, now the next is what? And this one, the coefficient of skewness is 1, or the measure of skewness beta 1 is 1. Beta 1 is 1, therefore the coefficient of skewness I am going to this is the skewness just I have shown you. Okay, and it is what? It is this distribution. This is negatively skewed, you know. It is what? Negatively skewed. Okay, as per the previous information. Okay, in this way we have solved the problems of moments in examination. You know, all the examination, so this type of problems are asked. Here mu1 dash up to mu4 dash are given, mu1 up to mu4 we have found, and here the data is given to you with frequency, and mu1 dash, mu2 dash, mu3 dash, mu4 dash we have calculated. After that, mu1, mu2, mu3, mu4 I have calculated. Beta 1 also we have calculated, and beta 2 I have calculated. Here beta 2 is what? It is less than 3. Okay, therefore it is again platykurtic. So we stop here. Thank you very much.